most of our people are in Cincinnati and Dayton because we like the personal touch. Don't forget, if you have questions, we have Slack going for you to ask those. We are in the orange room, so feel free to post questions. I'll get on afterwards and answer anything that's still unanswered, but if you know the answer to something that someone's asking, feel free to jump in and be a part of that conversation. All right, hopefully I talk a little bit slower through the rest of the presentation. I'm going to give this as a little bit of a case study. I'm going to focus on a specific client and project that we as a company worked with. Our involvement is mostly done. We're transitioning it over to the client team at this point. So it's over on their part, but we did a lot of work to get it set up, and I'm going to use that as the basis for a lot of what we're going to talk about today. The client is a software as a service company. They specialize in healthcare management, assessment, and reporting, and they work with a variety of clients, most of them government related somehow. The client that we dealt with on this one is actually the state of Ohio. The project was to rewrite a legacy case management application. They made the decision to rewrite it from scratch when the state asked for some changes in how assessments worked. The state asked for a brand new assessment that didn't fit with the existing model, and there were enough problems with the application that instead of trying to shoehorn the new assessment in, the decision was made to rewrite it, which is awesome. Greenfield development is a great thing to do. And so we got a chance to try out a lot of new things on this particular project. We needed a way to make sure we could migrate users with next to no downtime. Officially, we had to have 0 downtime. As we all know, that's not going to happen, but we'll keep it as minimal as possible. And then we got the chance to use a lot of new stuff. A little bit of backstory that helps us explain why we got here. Probably a decade ago at this point, the client was facing significant financial pressure and ended up making a decision to move their development from internal resources to external. That particular external firm got used for several years, and while the relationship was great to start with, ended up souring, and there were a lot of issues, lack of communication, a lot of problems that came up, and so our client decided to look for somebody new. They approached us in the fall of 2016. We assembled a dedicated team to work on their project and had a lot of issues in transitioning the work from their prior consulting firm in California to our office in Dayton. Part of that was a blessing in disguise because we ended up recreating all of the resources they had in AWS, which meant that we got the chance to re-architect some things in a way that was a little bit more sustainable, a little bit better to support, and meant that we knew what everything was and where it was. When we got the platform, there was a unit testing framework, but that's it. It was installed and the 2 sample tests were there, but they hadn't actually used it. No part of the deployment was automated. It was manually created and deployed Amazon machine images. They manually configured everything from the specific server environments to the auto-scaling rules, et cetera. And they hadn't used any kind of naming convention or picked specific regions within AWS. So it was very, very disorganized and very difficult to figure out if something was production use or development testing use, et cetera. In addition, because we were dealing with health information, we had to make sure that we followed the guidelines in the Health Insurance Portability and Accountability Act, or HIPAA, and Health Information Technology for Economic and Clinical Health, try saying that 5 times fast, or high tech. All right, if I haven't lost you yet, we'll actually get to the meat of the talk. This is a 100-level course, so we're going to go through some basics of AWS and make sure that everybody is up to speed and has a base knowledge before I start talking about the specific solutions that we're using. AWS has 54 availability zones across 19 regions, and they have announced 4 new regions and 12 new availability zones. The map that you're seeing on the screen right now is the locations of all of those geographically. The orange dots represent regions that are currently up and operational. The number inside is the number of availability zones in that region. The green dots are proposed or announced regions, and then they don't have a number because since they're not live yet, they don't have a specific number of AZs yet. How many people in here know the difference between an AZ and a region? Okay, not a lot of you. So let me explain the concept. AWS breaks things up into these two layers, and they're very pervasive in AWS whenever you talk about it. A region is a geographic area. Columbus, for example, is one of their regions. The availability zones are specific data centers within that region. Each of the AZs, or availability zones, if you work on AWS for very long, you quickly learn to call them AZs. Each AZ has redundant power, redundant fiber connections to internet backbones. They also, within a region, they have hardline fiber between each of them. So from a networking perspective, your latency is basically non-existent. You can do scaling, recovery, fallback, et cetera, across different AZs within a region for very little money, and it works from a coding perspective very seamlessly. To put that into specific terms, there's the Columbus region that I mentioned. It's one of the newer regions in AWS, launched in 2016, I believe. And then there are 3 AZs. There's one in Dublin, one in Hilliard, and one in New Albany. Now, I'm geographically challenged, so I like to see these things on a map. We are right about there. You have an AZ in Dublin, one in Hilliard, and one over in New Albany. Those are typically referred to within the code by their designations that I have in light gray on the left. Columbus is US East 2, and then each of the AZs is A, B, and C. One thing to note for those of you who are versed on AWS, those A, B, and C designations do not necessarily correspond to the city names that I have next to them. In fact, those differ per account. AZs are defined on an account level basis, so my personal account may have AZ as Dublin. My coworker David's account may have AZA as Hilliard. There's no way for you as a user to know where those map to, and Amazon has the ability to disable those for certain accounts. So right now in the Northern California region, which has been up for a while, there are 3 physical AZs. There are 3 data centers in that area, but one of those is nearing capacity, so existing accounts have access to it. New accounts that are started do not see the 3rd one. They only see 2 AZs in Northern California. So you have the ability from the AWS side to be flexible about how those are assigned. I've started throwing a couple of terms at you, but let's go through and get some basic terminology in place before we get too far into the talk, so we're all using the same lingo. The biggest one that took me a while to learn is that everything is an instance, not a server. With a few notable exceptions, everything in AWS is a VM, virtual machine. So they're all referred to as instances because they're not a physical server. Again, you can get a bare metal server. It's really expensive, but if you need that, you can. Even then, we still call it an instance to be consistent, but the vast majority of what you're dealing with is virtual. And so to make sure that that kind of sinks in from the ground level, everything's referred to as an instance. I've already mentioned AZ, or availability zone. This would be a data center. VPC is a virtual private cloud. It's most closely akin to a network, and this is where I had to learn a lot as I got into this process. My background is actually front-end development, so becoming the system admin for this particular project was a really sharp learning curve, but it was a lot of fun. And so for me, this most closely maps to a network in my mind. EC2, or Elastic Cloud Compute, would be servers or instances. This would be actual computers that run under the covers. AMI, or Amazon Machine Image, virtual machine. It's a machine image if you've ever worked with VM software. There's RDS, which is the relational database service. S3, simple storage service. This is probably one of the most common ones that most people in technology are familiar with S3, at least by name. And then you have EB, or Elastic Beanstalk, which is a solution that we'll talk about in a minute here. All right, that system that we're talking about has, the client has about 6 applications. Each of them have 3 environments. There's development, quality assurance environment, and a production environment. This diagram, which I'm not going to go into in detail, I'm showing you just to give you an idea of the complexity. This is one application's production environment. So we have 6 of those all operating within a single AWS account. It's been interesting to figure out how to make sure that we're maintaining separation of data across different production applications while maintaining access and making sure that we have tracking of who accessed what and when. There's a lot of stuff going on in there. With that complexity, it was hard for me to figure out how to break this up into a talk. So what I decided to do was to talk about it by technology. So we'll go through web servers, we'll go through databases. It made it easier in my mind. So we'll break it up by tech, and we'll talk about web servers first. On the legacy side, the existing, currently operating in production application, because we're about a month away from going live with the new one. So the legacy environment is hosted on leased servers in a shared data center. They're physical servers, which means if I need to add one, I've got to requisition it, I have to image it, I've got to get it all set up, get the connections put in. It's a big process. And as we've gotten through this development process, we found that there are fairly inconsistent backups, and in some cases, no backups at all, which is interesting when you're running production level data, healthcare data that we really don't want to lose. As we talked through this with the client, there was a need for scaling. There was a need to be able to expand and contract the amount of server resources based on usage. If I'm talking about usage at noon on the last day of the month, I'm talking a much different number than noon on a Sunday in the middle of the month. So it would be really nice if we could add capacity when we need it and get rid of it when we don't. We also needed a really easy way to deploy code. Like I said, the legacy environment was a difficult process. There's technically a way to do it with no downtime, but it's one of those stand on one foot and cross the other one behind your knee and hold your breath and hope that nothing goes bad. So we needed an easy way to make sure we could do rolling deployments that didn't affect consumers and had no downtime. We ended up going with Elastic Beanstalk. It's a managed solution where you can go into the AWS panel and tell it, I need X number of servers, I need these security groups, I need these scaling rules. You can fill it all out in a wizard, and it creates a whole bunch of resources for you with you having to know very little about the environment. And when I started the project, that seemed awesome. Going through and being able to click a button and set up an entire environment with web instances and load balancers and all of my IP filtering and port control and all of the security that you need was incredible. It also had the ability to monitor instance health. It will watch each of those instances that are in the production pool. If something goes wrong, it can automatically kill off the instance and spin up a new one. So you don't have to have a massive operations team sitting there watching it 24/7 to make sure that everything's operating efficiently and properly. It's based on EC2, so there was a lot of material online to help me figure out how to configure EC2 instances. There's a lot of coding approaches where you can write all of that in scripts and have the environment spin up and spin down instances as you need to. Everything is very, very configurable and controllable. What we found as we got into Elastic Beanstalk is that's all awesome, and it works really well for spinning up a proof of concept. It works pretty well for spinning up a development environment. As we've gone to production with a couple of the other applications for this client, and as we're getting ready to go to production with this client, what we found is Elastic Beanstalk doesn't meet the needs we have for production. It's a lot of work to switch, so at this point we've figured out how to work around it. But in general, all of that ease and all of that automated creation also limits you a little bit. And like I said, it's awesome for proof of concept. But one of the things that we'd like to do in next steps is move from Elastic Beanstalk to a solution called CloudFormation. CloudFormation is a tool where you can use XML or JSON, I believe, to script out your environments, and then CloudFormation can go through the creation process for you. So your entire environment can be defined in code, and can be used to generate out environments on demand, essentially. Right now, our version of this is a Word document that one of my colleagues put together that's 30 or 40 pages long and walks through an incredible number of steps, and really, if you don't know much about AWS, you're probably going to have trouble. It works, but we found that we have trouble with getting really nitty-gritty on some of the scaling rules that we want to do in production. We've also had trouble with maintaining software updates and OS updates, being able to control exactly what's installed on the machine. There's a lot of small issues that become apparent when you run at production scale. We also want to, as a stopgap, before we can go to CloudFormation, we want to make a change to the deployment process in Elastic Beanstalk. Right now, when we deploy new code, it installs on top of the existing server. So the standard rolling deployments will take a server out of the production pool, install the code, test it to make sure it's good, and put it back in. There is an option in EB to actually kill off instances. So it will spin up a new instance, install your new code, put it out, and then kill off an old one. And that'll give us a stopgap until we can get to CloudFormation and really control all of the details. Because it's an entry level, I will show you some of these screens. We've got 3 applications, or 3 environments, like I said, for this application. So we have a sandbox environment, a production environment, and a testing, or what we call staging environment. This is the Elastic Beanstalk screen inside of AWS, where you can see all of the environments with some basic information. They also show up in big, bright colors to tell you what the status of the environment is. So with all 6 apps, this is a really, really long page, but you can easily scroll through it and see bright red, yellow, or green, depending on basic status of the environment, and easily zero in on where there are problem points. Once you get into the application, in this case production, you can go in and see on a server level or instance level each of the instances that are currently deployed. I took this during the day yesterday, so we were at the production middle of the day number of servers. Pardon me. This isn't launched to users yet. We're in final preparations for that. So the columns with the little dashes in them are all individual numbers of 300 responses, 400 responses, 200 responses, et cetera, memory usage, et cetera, things that would be very important once we're running users, but since we don't have users in the system really, it all shows zeros at the moment. You can also go into the EC2 panel and see all those servers, as well as some basic status checks at the OS level, make sure that the server itself is running as it should. And on the EC2 panel that I'm showing here is where you would go in and find information about connecting to the instances directly, what SSH key that particular instance is set up to use, connection strings you need to be able to remotely connect to the instance, etc. And then there's something called a security group. This is where you would maintain restrictions on what IPs can get into what ports, whether that's port 80 and 443 open to the world, or port 3306 open to your database servers, since we're using MySQL. You can have a variety of security groups attached, and this screen in the EC2 panel is where you see those. As you can see, for our OHC application, we have a lot of them. There's a scroll bar on the right, so you've got even more below the screen. But this is where you would go to see all of those and be able to configure specific rules for each group. Okay. All right, so databases. Like I said, I'm a UI developer, so we're getting further away from my area of comfort. But again, this is one of those areas where AWS makes it really easy to configure these things. And as we've gotten up and going, we've worked with our various database experts to tweak these to be more performant and meet our needs more easily. In the legacy app, again, we're looking at leased servers in a shared data center. We have physical servers, inconsistent backups. We found there was a problem in production where we went back to look at a backup and we found that there were 6 weeks worth of backups that were corrupted and nobody had noticed. So we've got some interesting concerns there. In addition, the legacy system is using Microsoft SQL, which, while it's very easy to work with and has a lot of pros, it also means that there's some pretty high licensing costs there. So we were looking to see if we had any way to reduce any of those costs. Again, we have PHI and PII concerns, so we needed to make sure that we were running encryption at rest, as well as throughout the entire system. We needed to have regular, automated, simple backups that were easy to restore and had proven paths to rollbacks if necessary. We also wanted the ability, and this was a nice to have, to be able to scale those servers as the need arose. It's one thing to import all of the data from a legacy application, but as you get up and running, it's hard to predict how much disk space you're going to need, how much I/O you're looking at, how much memory you're looking at. And so one of the nice to haves was some way to be able to pick the size we need now without having to be as specific and accurate about how much we would need 6 months from now, a year from now, 2 years from now. We ended up going with AWS, RDS, Relational Database Service, and their Aurora database. Aurora is essentially MySQL. You use all the same tools to access it, but they've made some minor tweaks to support the shared data center model that AWS is running on. In addition, handling some of the cloud environment specific things, making sure that they can run separate database instances that don't have access to each other, and control and make sure there's not paths down at the database level to get across to other data stores. RDS also provides a very flexible instance sizing model where you can go in and scale up or scale down both the physical size, the drive size, and through that the I/O. You can also control the processor sizes and numbers of cores with that scaling, and that's very easy and built in. In addition, one of the things that makes this really handy is the backup schemes. It keeps every transaction for the last 24 hours, so I can roll back at a transaction level anything that happened over the last 24 hours. It then pulls a daily backup that it stores for a configurable amount of time. You can go into the settings for that particular database and keep it for anywhere from 0, you don't want to keep them at all, to I think 35 days is the longest, and then those are automatically deleted at the end. You can also maintain hot standbys in the same region or the same AZ, a separate AZ, or even a separate region, depending on what your particular disaster recovery plan calls for. In most cases, those hot standbys can also be used as reporting servers. So there's an endpoint that's generated for you automatically as part of the process that's a read-only endpoint, which gets load balanced among all of your backup instances. So you can run large reporting jobs against a non-real-time server that doesn't impact users while maintaining the ability to fall over to them if necessary, very, very simply and easily. Some of the things that we need to get done and that we recognize are still lacking in our system are an automated process to pull things from production into lower environments. We've started this, and there's some progress on it, but we do need to finish that out, make it a little bit more smooth, and make sure that we've included the ability to scramble that PII, make sure that we're masking sensitive data when it comes down into a lower environment. We did a little bit of work to try to make sure we picked the right database when we stood things up initially, but now that we're up and running, we need to go back through and make sure that based on actual usage and actual numbers, we've adjusted the size of those databases. Obviously, a larger database costs you more, so one of the benefits of that ability to change the size very easily and very quickly is the ability to make sure that you are running things at the least expensive option available. One of our goals, one of my goals anyway, and I think I've got most of the dev team convinced, is we want to change to use Aurora serverless in some of our lower environments. Aurora serverless is a new option from AWS that is currently in limited release and testing. I don't believe it's released to the public fully available yet, but it uses the same interface as Aurora, which is their MySQL clone. It uses the same interface and technology as Aurora, but it's done in such a way that you only pay when you're actually using it for compute time. You still pay for storage all the time, but you would only pay compute when you're actually using it, a lot like AWS Lambda, if you're familiar with some of their other serverless options. So for something like a development environment or a testing environment where we're not using it all the time, where it's got some peak usage, but I mean, let's face it, devs don't work 24 hours a day. They might work 21 in the case of a couple of people I know, but not a full 24. So there's a couple of hours there where we don't have to pay for that compute instance, which again would lower our bill. AWS is rolling out a new console look, so you're going to see this in a couple of the slides. This is the RDS console that lists all of the databases we have as of yesterday morning when I took these screenshots. All of the database instances we have up and running for this particular application. Those top two are going to be production. So I talked about having a hot standby and a different AZ. The first one in that list is the one that's actually running. It's the primary or master. And then the second one in the list is going to be your backup that we run in a second AZ. For cost reasons, we only run that for production because you are paying for two database instances that way. But for production, you need to make sure that you've got those backups and that real-time DR plan in place. Then for the rest of the environments, we've got our staging environment I talked about, development, and then there's also some testing servers where developers can actually hit those in real time off their machines. These databases are, we've found, much too large to be able to host a representative data sample on a developer's local machine. So we actually have instances set up that they hit from their local machines over the VPN to be able to do development. And then zooming into a specific database, you've got some basic information about that DB, what engine it's running, what AZ it's in, how big it is, as well as some metrics. And again, we don't have active users on this particular system, so those graphs look pretty flat, but we are doing some data moves and migrations to test those processes. All right. Document storage is a key part of the application. You have the ability to upload signature pages, care plans, a lot of information about the client, so we had to make sure that this was taken care of. In the legacy environment, since there wasn't scaling, those documents were stored on the physical web server, which means that you really can't scale. In addition, we didn't have a specific document backup strategy in place. It was the backups of the server, which, as I mentioned earlier, were not necessarily all that regular or dependable. In addition, it was difficult to find documents. As we've gone through the process of getting everything ready to migrate, we have found documents stored all over the drives on those servers. Some of them are on the C drive in folders that are hidden down in the file structure there. Some of them are on second or third drives on the servers. They're all over the place, and it makes it difficult to find them, to move them, let alone if a client comes back and says, you lost a document. It takes us quite a while to figure out if it's actually lost and where it's stored, et cetera. So we moved to S3. In the new system, we're putting those in the simple storage service, or S3. It's got a very clean and unified structure to put those in. They're called buckets, S3 buckets, and they're done that way because really it's a collection of items. You can store anything in S3. You can run active websites off of it, or you can use it as a file cabinet. It's entirely up to you. It's very, very flexible that way. In addition, AWS provides those redundancy protection. For those of you that don't want to count, that's 11 nines up on the screen. To put that into slightly more manageable terms, and I'm pulling this from the AWS website because I wouldn't figure this out myself. If you store 10 million objects in an S3 bucket, you can expect to incur the loss of a single object once every 10,000 years. For our purposes, they're not going to lose anything. So we've got a lot of redundancy, backup. Behind the scenes, when you store something in S3, it's a basic request system, put, get, type logic. It's very, very simple to use from a coding standpoint. When you do a put request to add an object to the system, behind the scenes, AWS actually makes sure it is stored in 3 separate availability zones and stored successfully before you get a success response back. That happens very, very quickly. It's not a delay on your side, but you know when you do a put and you get a 200 back from that request, that you've already dropped that thing into 3 separate data centers, and afterwards it replicates out to a few more. I want to say it ends up in about 6 of them total. So they really do a lot to make sure that when you drop something in S3, you're not going to lose that. Again, here are some of those screens. So this is the basic S3 screen listing buckets, and I've filtered it to only ones for that particular application. You can see on here whether or not it's public. We've all heard about some pretty public data breaches for S3. So this column is fairly new in the dashboard. They go through and look at a number of different factors from a bucket level. You can still set specific files to be, or specific objects to be public if you need them that way. And this won't necessarily check for that, but it will look at bucket overall permissions and let you know if you've got a bucket that is open to the public, so that it's very easy for you to see what's public and what's not. So it's easy to go in here and catch those problems. It also tells you what the primary AZ is for that bucket, where it's going to try to store things originally, as well as the creation date for that bucket. When you open up a bucket, you get a list of objects. In our case, we're using a set of identity numbers as file names. That all maps back to a database table where everything is stored. We know what the uploaded file name was. We know what the updated file name is if the customer has, or the user has decided to change that file name. We know what the extension was. All that jazz is all in the database table and maps to these IDs. And then when you click on a specific file, you get information about that file. One of the things on here that I'll highlight is the storage class. It's in the properties section on the right-hand side, down towards the bottom. This one is in standard storage. For a variety of reasons, that's what we're doing here. We've got another client where we can flex with that. Storage level is how you would control cost in S3. So I have a client that we're working with right now that does electronic signatures on documents. And so they have the ability to upload PDFs and sign them. We store off a copy once everybody's signed and agreed and everything as reference. And those, we actually have automated rules that move them through the storage classes. So we know that in general, those documents are only accessed in the first couple of months. So we've set it up that we leave things in standard storage class for about 2 months from date of creation, and then they move to standard infrequent access. Your fee to access the file goes up a little bit, but your fee for storage gets cut in half. So it's a much cheaper way to store things for the long term. And then for legal reasons, they've decided that at 18 months, they don't want to store it at all. They want it completely gone from the system. So again, we have another rule in place that will say 18 months from date of creation, this gets deleted and removed from the system. And all of that is configured within the S3 console. It doesn't require manual developer intervention, doesn't require business person intervention, and it doesn't require any special coding. All of that is set up once in the rules and then runs from there. All right, infrastructure. In the legacy system, there aren't testing environments. Again, we're physical servers with no scaling. I'll skip that, we've hit on it a few times. So now, all of those 6 applications, like I mentioned, have 3 different environments: sandbox, staging, and production. Each production application is in its own VPC, virtual private cloud, and the access for those is restricted and monitored for compliance with the various regulations that we have to be compliant with. Every production and every environment, period, is set up to scale based on usage. So our production environments have use-based scaling, where we know if your data flowing out, there's reporting, so we looked at the data flowing out metric on this particular client. If that hits a certain point for a certain period of time, we need to add servers. If it goes under a certain point for a set period of time, we need to remove servers. In addition, we know that since we're dealing with a user base in Ohio that's in the Eastern time zone, 8 to 5 Monday to Friday is going to be your standard hard hitting. So we have time-based scaling in addition that at, I think it's 7 or 7:30 in the morning, adds several servers, and at 6 o'clock at night takes out several servers, so that we know when people come into the office at 8, I've got additional capacity to hold our typical expected volume, and I can still scale up and down from that point based on specific usage that day. Likewise, our development environments from a web instance perspective are set up to scale the opposite way. So, like I said, devs don't work all day long. On projects, on applications where we aren't specifically focusing development effort, we actually have those set up to scale down to 0 servers overnight and over the weekend, so that if I don't have developers working on it, I'm not paying for that web instance time. So you can scale both ways, depending on what your needs are. In addition, we can make sure that the infrastructure in that environment is right for that environment. If I'm running a document process in both dev and production, I can afford to have my dev wait an extra couple of minutes and run a smaller server size there, because they're not going to do that as often, so it's a lot cheaper to run a smaller instance. In production, I want things as near real time as I can get them, so I'll jack that instance up more where it makes business sense to spend that money on a beefier machine that can process those documents more quickly. All right, and then here we start talking about some of that infrastructure. So this is a list of all of the VPCs that we have in that system. This isn't just for the application I've been showing, this is all of the VPCs in this particular account. One of the things that we found that I'll mention here, because I'm realizing I don't think I included it later, one of the things that we found was it makes things a lot easier to manage from an infrastructure maintenance and code deploy standpoint if you have a separate VPC to handle those operations. Things like TeamCity. In our case, we're using TeamCity for the deploys. And so those TeamCity servers and agents are hosted in their own VPC that has specific connection rules to the other VPCs. It allows us to very easily segregate those resources, control exactly how they can interact with the rest of the infrastructure, and separate them on things like bills and reports, so I can see what costs are infrastructure-based costs that are simply a cost of doing business versus what costs are directly driven by client demand. If their servers are scaling up an obnoxious amount, I can see that that is the reason that my bill went up this month, because I've got a lot more servers there, so they're doing something weird, or I've got something odd in the code, versus we ran a few more deploys, so I have more time on a deploy instance. All right, this is subnets. So I mentioned that VPCs are like networks, and I liken them that way because you have a lot of the same things that you can do in there. These are the subnets that are within that application's production environment, that OHC application's production environment. So we can set up subnets, we can give them IP masks or CIDR blocks, we can pick which availability zone they're in, and control all of their access through route tables and internet gateways, et cetera, just like I could if I was running a network in a physical data center. It really gives me all that same flexibility and allows some interesting connections. So if you've got on-prem infrastructure and want to connect it to the cloud, you can do peering to connect your local on-prem infrastructure with the cloud and make it all function as a single network, even though you're in 2 separate locations, just like you could with 2 separate on-prem data centers. You can connect those over the internet as well. So this is now into the EB setup, so the Elastic Beanstalk setup for that environment. And this screen is really, really long, so I didn't try to get the whole thing in a screenshot. But this is where you would go in to do that capacity. I talked about scaling based on data out. I talked about scaling based on time. All of that is set up here. And you have the ability to do that in a very, very simple, easy-to-use interface in EB. So it's great for figuring it out, for setting it up in a dev environment. And then you can take those settings and use them to set up your production environment in CloudFormation, for example. All right, some general lessons learned in next steps. I mentioned separating general infrastructure. Not only does it help with the billing side of things, making sure that you can easily separate and segregate costs, it also works really well for control and any kind of access monitoring to be able to have those things separated out. I keep harping on this because it's been a big pain point for us. EB is great for rapid prototyping and initial development, not so great when you get into production applications, just because it's more limited and doesn't give you the fine-grained control that most devs and system admins like to be able to have. The last thing I'll say is, in the lessons learned, is take advantage of AWS tools to minimize your spend. I've mentioned several times being able to scale things, use smaller instances when I can to reduce that spend. AWS knows that it's in their best interest to make sure you spend as little as possible to do what you're doing, because if it's cheaper, it's easier for you to convince your boss to do more. So if it's cheaper for you to host a single application, it's much more likely that you're going to convince your boss or the decision makers that you deal with to host 3 or 4 or 5, which over the long term means that AWS gets more money. So they do a lot to try to help you spend less. There is a tool called Trusted Advisor. It does cost money, but you can turn it on for a couple of months and turn it back off. It gives you a lot of things. So they break everything in their infrastructure down into these 5 categories, and then give you general scores on items within each of those categories. The biggest one is the far left, cost optimization. This client that I'm talking about, their bill for April was $22,000. If we were able to follow every piece of advice in Trusted Advisor, we could cut that by over 30%. Now, there's business reasons why we can't do everything Trusted Advisor is suggesting, but there are some of the things that it suggests that we could do. There are things like reserved instances, which allow you to pay a lot less because you guarantee AWS that you'll have the capacity. If your production environment, like this client, never goes below X number of servers, for this client, the apps that we actually have in production, neither one of them go below 2 servers ever. So I know that I'm always going to have 2 servers. So I can go to AWS and say, I want to promise you that I'll have 2 server capacity up, 2 instances worth of capacity up for the next year. AWS will say, okay, here's the deal. It's built into the system. You can go in and get a lower cost for those because you know you're going to be using them. If you're running an app that's going to be up for the next 3 years, they also do 3-year pricing, which is even less and saves you even more money. So there's that. Cost optimization will also go through, I'll show you here. It'll go through a lot of different things. It'll tell you that you've got database instances that, based on processor and memory use, look like you're not using them at all, or look like you could go to a smaller instance. Again, there may be business reasons to stay where you're at, but if there's not a solid business case, this will be a great tool to go in and say, here's a reason why we could, or why we should do this to save us money, because when it comes to business decisions, it's also often driven by money, like we all know. So this worked really well. The other thing that comes into play, all of the categories really are important, but you've got things like fault tolerance. Security is a big thing. Like I said, we've seen a lot of data breaches out of S3 in the last couple of years. It'll go through and evaluate your security posture. It'll evaluate your fault tolerance. In some cases, you still need to bring in an expert, but in a lot of cases, this will cover most of the basics for you, and even some of the more advanced things. So Trusted Advisor is a great tool and works really, really well. I would highly recommend spending some time and money on it because it really is a great resource. As I am wont to do in these talks, I talked really fast, which means I'm done 15 minutes early, but thank you for listening, and if there are questions off of Slack or in the room, I'm happy to try to answer those. Does CloudFormation use Kubernetes? I am not sure specifically if CloudFormation will allow you to use Kubernetes. AWS does have container options available. There is Elastic Container Service that uses primarily Docker, and there is Elastic Container Service for Kubernetes specifically. So you have the ability to run containerized options. This particular client doesn't run containers, so I didn't cover that in the talk, but there are container options both for Docker and Kubernetes that are available. Okay, well, if there's no other questions, then I'll give you back 15 minutes. Enjoy the rest of the conference, and thanks for coming.